explanation. All right. So we are going to review the combinations of translations that we talked about and put it all together. We'll practice one more and then we'll move on into 6-4. So first of all, what we did is we found where the period needed to start, where it needed to stop by solving a 3-part inequality. In other words, whatever showed up here, we sandwiched it between 0 and 2 pi, right? And then we would know where the graph needs to start, where it needs to stop for one period. Then, how many equal parts do you have to divide this into? 4 equal parts, which means you actually get 5 key x values, because it's either going to fit hala or a hala, depending on whether it's a cosine or a sine. Then you go back and you evaluate the function for each of those x values using either hala or a hala, and you find the points that intersect the line y equals c, which would be the middle points of the wave. Remember, on this, that's when we have a vertical translation. So instead, when we're talking about axis, if we've had a vertical translation, it's not where it's crossing the x-axis, it's going to be where it's crossing this c value, because we put a little dashed line when we did this the other day to remind us here's where our new axis point is. And then you can go through and plot your points using whichever curve is appropriate, sine or cosine, and make sure that you have adjusted your amplitude by whatever the a value is. What we did is we multiplied our values from hala or a hala by that a, so we knew here's where our angle measure needed to be, here's what the amplitude is above or below that dashed line. And then you would draw in your curve if you need more than one period. Yes?
There were still 2 blanks we didn't fill in.
Oh, sorry. Okay. And so what, yeah, I should have pointed this out, because when we're putting those x values on there, besides crossing wherever c is, we're either going to have max or min points because it's a high or a low. Okay, thank you. I did leave that part out. All right. And then, like I said, we can extend it out if we need more than one period. So if we are following the steps of how to graph, we know that looking at this when there is no vertical translation, the amplitude is simply what? Which letter? A. And it's always the absolute value of A, because remember, if there's a negative sign in front, that tells us about reflecting over the x-axis. We know we can find the period by doing 2 pi over b. You don't have to sandwich between 0 and 2 pi if you don't want to on this, because you didn't have any kind of horizontal translation. And then we can use that information to graph the functions. So we're going to go c units up as long as c is greater than 0, and c units down if c is less than 0. And so horizontal translations mean that we go d units to the right as long as, and let's just leave that part blank, because that's based on if it's x minus d, and it gets confusing. I think you guys understand whether we're going to the right or the left, because we practiced that quite a bit. So let's see if we can get this thing graphed over 2 periods. So can you tell me where you would start? What would you find first? All right, so you're noticing that the amplitude is 2. Okay, now, and you said the axis is at 4 because I've got that vertical translation up. So if I were to mark off 1, 2, 3, 4, I know when I get ready to graph. So we've taken care of amplitude, and we have taken care of the vertical translation. And amplitude in the sense that now I know at a maximum I'll go up to 6, at a minimum I'm going down to 2. Okay, now I can also adjust that whenever I use either holla or a holla in a minute. But what am I going to need to do to figure out where this sine curve needs to start and where it needs to stop? Okay, do I want to just find the period, or is this one of those sandwich problems? I would sandwich it between 0 and 2 pi. So if I were to take 0 is less than or equal to 3x minus pi, which is less than or equal to 2 pi, do I have anybody who's confident enough? You want to come up and show us how to do this on the board? Okay, so you want to go ahead and fill this part out together, and then I'll get somebody to come graph it, right? Okay, let's do that. So tell me what is it I'm actually trying to isolate and solve for in the middle? X. So what would be the first thing you do? Add pi. So I'm going to add pi in how many places? 3. It's got to be on each side of an inequality. So pi is less than or equal to 3x, which is less than or equal to what? 3 pi. And now I will divide everything by 3. So here's what I know. My period will start at pi over 3, and it will complete at pi, correct? Okay, so I know pi over 3 is going to be my starting point. So here's where 2 pi, 3 pi over 3, which is just pi, right? So I've got 1 pi over 3, 2 pi over 3, 3 pi over 3. And I need how many points to be able to get this graph? I need 5. I can see where the middle point is. This is going to be what? Well, what's going to be halfway between pi over 3 and 3 pi over 3? 2 pi over 3, right? Remember we said we could add these together. A pi over 3 plus 3 pi over 3 would be 4 pi over 3. And then you multiply that times 1/2. 2 goes into 4 2 times. That means this is 2 pi over 3. Okay? But now I'm going to have to do what to figure out what this value is that needs to be in between here and here. Add those together and do what? Very good. So if I add pi over 3 plus 2 pi over 3, I get what? I get, 3 pi over 3, which is pi. And then I would have to multiply pi times 1/2. Oh my, what is this? Pi over 2. Now, what's going to be in between these two guys? If I add 2 pi over 3 plus 3 pi over 3, I get 5 pi over 3, but I have to multiply that times what? 1/2. And that's going to turn into 5 pi over 6. All right, how comfortable are we in being able to find these 5 key points? We good? All right, and then because it is a sine curve, I'm going to want to use what to help me graph it? A holla. Sine starts at the axis, right? So I'm going to do a holla. And what we know is that these are going to be my 5 points. Instead of 0, we're going to start at pi over 3. We'll go to pi over 2, then 2 pi over 3, then 5 pi over 6, and pi. Right? Because our period got adjusted. Now, normally, a holla has, so these are my angles. My ratios are normally what if there's been no transformation? 0, 1, 0. But because we had this amplitude change, okay, my amplitude is 2, but notice what else is here? A negative. What would I want to multiply all these by? If I multiply everything by a -2, that'll give me, it'll take care of the reflection and the amplitude change, and I'll know how many to go above or below to mark these. So this would still be 0. This would become 0. Good. Negative times negative gives me a positive, and this would be 0. Now remember, this isn't exactly where I am on the graph. This is how much above or below where my new axis is. If you want to know exactly what the y value is, this is where you could come back, and if you wanted to add 4 to all these numbers, then it would give you the exact y values. All right, so it's up to you. If you're good with anywhere I see a 0, I know that means that's my axis point. Then what I would do is say at pi over 3, I'm on the axis. At pi over 2, I go down 2. So I'm going to be right there. Back at the axis here. I was going to have somebody come and do this, but I did it anyway. And then I go up 2 units above this at 5 pi over 6. And then I'll be back at the axis. Now, that's how many periods? That is 1 period, but it wants me to graph this over what? 2 periods. How would I do that? Do you want to keep going in a positive direction, or do you want to go back in a negative direction? Well, that would be true if we hadn't had a horizontal shift. But since we've had a horizontal shift, we can't just flip it. Here's a suggestion. Figure out exactly how much you had to add to get from one unit to the next. This, to me, is the easiest one to see. Go from 5 pi over 6 up to pi. What did you add to this to get there?
Or 1 pi over 6.
Pi over 6. 5 pi over 6 plus 1 more pi over 6 would give you 6 pi over 6. If I did this one, 2 pi over 3 is the same thing as 4 pi over 6, right? If I add another pi over 6, I'm in 5 pi over 6. So all of these are pi over 6 apart. So you can go either way. If I want to go in a positive direction, this would be, that would be 6 pi over 6 plus another pi over 6 is 7 pi over 6. Add another pi over 6 to that, it becomes 8 pi over 6. What will that reduce down to? 4 pi over 3, okay, which was 8 pi over 6. Now, if I add another pi over 6 to that, this is going to be what? 9 pi over 6, but that's going to reduce down to what? 3 pi over 2. Now, let's see where we are. If I'm following my curve, this should be where? A low point, so that's going to be a 2. This should be axis. This should be a high point. I just need 1 more, and I'm back at my starting position. So if I take 9 pi over 6 and I add another pi over 6 to it, that's 10 pi over 6. Reduce that guy down. What do we have? 5 pi over 3. And now I have 2 periods. And we could have gone to the left. We'd just be subtracting pi over 6 from everything. Make sense? You got that. You got the big picture of everything. Now, we're going to see if we can take care of the tangent and cotangent today. You'll have to wait a little bit. We'll do it in a little bit. And then we could apply any of these transformations to any of these other graphs. Now, if you remember anything about the tangent curve, that's the one that looks like this. It looks a lot like a cubic function. And we have these vertical asymptotes because remember, we end up with a problem when you get 0 in the denominator, right? And because tangent is opposite over adjacent, on some of those axis angles, you end up with an adjacent value of 0. So that means that we have these asymptotes that show up periodically. that there are these places where the tangent doesn't exist. Now, because of that, when we talk about one period for the tangent, that means we want one complete graph. And we're going to, so in other words, we got to figure out where these asymptotes occur. And anytime we're restricting our domain on these functions, because we want to be sure that we have something that's a one-to-one function, so that if we take the inverse, it would still be a function. It's going to restrict it either to be a first and second quadrant graph or a first and fourth. Okay, we wouldn't want to take the part of the tangent curve where we get this piece, here's our asymptote, and then have this piece. We want it to be a continuous section. So that's why on the tangent, we're going to need to go from negative pi over 2 to pi over 2. So we get one complete graph, and it's bounded off by the asymptotes. All right? And if you think about all students take calculus, well, whether that would help you or not to decide. Just remember, it's going to be a first and fourth on the tangent, okay? So let's look at what some of these values would be. At negative pi over 2, that's where this thing is what? What's my tangent ratio? If that's where the asymptote is, it means that the tangent is undefined, right? Okay? If you were thinking about a negative 90-degree right triangle, that would be the idea that we would have this triangle that's squeezing closer and closer and closer to here. And if we were to calculate what that value would be, since my angle is here, there's my opposite, but what's happening to this adjacent side? It's approaching 0. That's why it's undefined there. It will also be undefined at pi over 2. Now, we do get values in between. Negative pi over 4. Pi over 4 is how many degrees? 45. So what's the tangent ratio in a 45, 45, 90? 1 over 1. But if I'm in the fourth quadrant, my tangent ratio is negative. So that's a negative 1. The tangent of 0 is 0, because if I'm looking here, my opposite is 0, my adjacent has a value, it would be 1. And then pi over 4 is a positive 1. Now, as far as your domain, it's kind of confusing the way that it's written. I'm just going to tell it to you. You're not responsible for being able to regurgitate this. But it simply means in set notation form, we would want the set of all x's. A vertical line means such that x cannot equal any multiple of 2n plus 1 times pi over 2. In other words, we're explaining how you figure out where all those vertical asymptotes are. Okay? So I would pick some number for n, like 0. 2 times 0 is 0. 0 plus 1 is 1. 1 times pi over 2 means I don't get a tangent value at pi over 2. Anytime I put something in for n, it'll show me where all those asymptotes are. But now my range is from what to what? Negative infinity to positive infinity. What I do know is that my graph is discontinuous. We have those asymptotes at values of x in the form x equals this 2n plus 1 times pi over 2, because that's how we figure out where they are. And those are vertical asymptotes at those values. Now, if I want to know where x-intercepts are, I know I have one at 0. Guess where else I have one? At pi. Those x-intercepts are going to occur at multiples of pi. They would be pi, 2 pi, negative pi, 0. The period is what? What is the interval that it takes to get one complete cycle of this graph? From negative pi over 2 to pi over 2 is pi. My period is only pi on the tangent graph, okay? I've got the full everything included in a period of pi. I have no minimums or maximums, so the graph has no amplitude, okay? It has no amplitude. It is symmetric with respect to what? What do you think? To the origin, very good. It's not symmetric to the x-axis. If I flip, the halves don't match up. So if it's symmetric to the origin, what kind of function is it? Do you remember? Even or odd? Odd. When it's symmetric to the x-axis, to the y-axis, that's when it's an even function. And because it's odd, it means if the sign of x is changed in the tangent function, it will change the output sign. So tangent of negative x is equal to the negative times the tangent of x. Now, cotangent, the difference is my graph is turned the other direction. And just like sine and cosine kind of have a period shift, this one does too, because my asymptotes don't appear at negative pi over 2 and pi over 2. They appear at 0 and pi. So I still have the same period. It's just it starts and stops at a different point. We'll go back and we'll talk about this. These are easy to graph. We're going to focus on sine and cosine. So when we come in on Tuesday, we'll kind of practice a couple of these to make sure we've got tangent and cotangent down. And then I'll explain what you would need to know about cosecant and secant. But when it comes to being able to apply all these transformations, we're going to focus on sine and cosine. So we've already hit the major points, and we'll wrap this up. Now, I do want to give you one more thing before you go. Wednesday will be our test. No, not Wednesday, Thursday, next week. So I'm going to go ahead and give you the review so you can work on what you can, get an idea of what to expect. And then, after we quickly wrap up any remaining notes, on Tuesday, I'm sorry, good catch. Then we will work on this in class. Okay. All right. When I get quizzes graded, I'll load those into my math class. Okay, just 1 minute. Which one is it that you're working on? You just had the one sheet, right? Okay.